Hello all, welcome to another lecture on the topic of probability. If you read a newspaper or listen to the radio or watch television, you have encountered statistics about a number of different topics. If you watch sports, for example, basketball, hockey, baseball, or soccer, you might have heard about statistics about different players. Statistics is the collection and analysis of numerical information. And we'll be discussing statistics in a separate series of lectures in detail. But for now, what statistics is the collection and analysis of numerical information, and of course, displaying them. What is data? Data is nothing but facts or pieces of information. For example, if such and such a soccer player scores like one goal per one game, then that is a piece of information. About basketball players, you might have heard about their shooting percentages and all sorts of different statistics and the number of rebounds or number of dunkings they have done in different games. There's an example here. It says a basketball player made 40 out of 50 free throws in summer games. So out of 50, 40 free throws were made. If he averages 8 free throws per game, okay, how many of them should he expect to make? That's what the question is asking. So we need to find the experimental probability first to see what is the probability of this basketball player making the free throws. So we're going to say, okay, probability is equal to number of successful trials, number of times that he made the free throws, which is like 40, and then we're going to divide it by 50, the total number of times that he actually had these free throws. So total number of free throws, that's in the denominator, and the number of successful free throws made is actually 40. So 40 divided by 50 is going to be 0.8. Okay, so the probability of this basketball player making the free throws is 0.8, or you can say it is 80%. Okay, so that's what we can easily calculate from the data, from the facts, from the pieces of information given to us in the problem. But then it says if he averages 8 free throws per game, how many of these 8 free throws should he expect to make, basically? So we're going to say, well, the probability of making the free throws is 80%. So if he has 8 free throws per game, then 80% of that 8 free throws is what we expect him to make, actually. So we're going to say number of free throws expected to be made is going to be 8, which is the number of free throws per game, times the probability, which is 80%. So 8 times 8 is going to be 64, so 0.64, that's going to be the number of free throws expected to be made. But so 8 times 8 is 64, but then I think I made a mistake here. It has to be 6.4, because we have one decimal here only. So 6.4 will be the answer. But the thing is that the number of free throws must be an integer, must be a positive integer. It cannot be a decimal number. Therefore, we have to round off our answer. So this is approximately 6. We can round it down because 6.4 is closer to 6 there than 7. If it was 6.9, I would say it's roughly 7. So the answer is 6, actually. So this person who averages 8 free throws per game, we are expecting him to make 6 free throws per game. That's our expectation. Again, that might not happen. He may even score everything, 8 out of 8, or maybe 7 out of 8, or maybe, as we said, as we expected, 6 out of 8, maybe he scores, but maybe, I don't know, for some reason, he makes only 3 free throws. So that is the exciting part about experimental probability. But in terms of our expectation, the answer is 6. So we are expecting him to make 6 free throws. This is another example here. We have a dart board here. It's a sports. The dart, I have not played it, but many people play darts. During a game of darts, 32 out of 40 landed on shaded triangles. So this is a unique dart board. It has congruent triangles. Some of them are white, some of them are shaded. So 32 out of 40 landed on shaded triangles. What is the experimental probability of landing on the shaded triangles? The question says. Okay, so it's just like an experiment. Probability of shaded, I should say, or landing on the shaded triangle. It would be number of successful trials, which is 32, because 32 times when they did throw the darts, it landed on the shaded triangles. So that's the number of successful trials, and the total number of trials was 40. So you divide them, and this gives you, I believe, if you divide top by 8, it's top by 4 is going to be 8, bottom by 4 is going to be 10, so 0.8 or 80%. So that means that the experimental probability of this dart landing on the shaded triangles is 80%. That's what happened in this experiment, okay? And maybe if we repeat this experiment, we get a different answer, because maybe not 32 times, but maybe like 26 times out of 40, the dart would land on the shaded triangle. We don't know. But according to the facts and pieces of information, according to the given data, that's the experimental probability, 80%. Now, what is the theoretical probability of landing on shaded triangles? Well, if you look at the divisions in this unique dartboard, we have 4 congruent white triangles, and also we have 4 congruent shaded triangles. So in total, we have 8 congruent triangles, out of which 4 of them are shaded. So I would say the probability of a dart landing on the shaded regions is going to be 1, 2, 3, 4, because we have 4 shaded triangles. So 4 divided by the total number of triangles was 8. Okay, so that gives us 1/2, or 0.5. That is 50%. So the theoretical probability of landing on shaded triangles is 50%. Okay, but this person, I guess, was lucky, because this person, or maybe he was very skillful, he was very good at this game of darts. Out of 40, 32 landed on the shaded triangles. So his experimental probability was 80%, but we know that theoretical probability was 50%. So this person was, I would say, a little bit either very skillful, or he got lucky. And if he repeats this experiment the next day and throws the dart 40 times, maybe this time he can only hit like 16 times, 15 times. Like the dart would land on the shaded triangles 15, 16 times. Maybe he would not be that lucky, and probably would be actually less than 50%. But theoretically speaking, we are expecting a person to throw the darts such that it would land on the shaded triangles 50% of times. Okay, so I hope these two examples are useful, and you know how to deal with, like you learn how to deal with these kind of questions. Thank you very much.